Nile from CS 2021, and I'm here to give my AI module summary review for artificial intelligence in the course offered by Dr. Saleh Raza for module number 2. So, starting off with module number 2, we started off by learning about supervised learning. So, what is supervised learning, you'd ask? Supervised learning is basically part of ML, machine learning, in which you have a function that maps an input, which is like, let's say, the x, to an output, which is the y, and input output pairs, right? And it trains itself based upon that. So that's versus unsupervised learning. So these two types of learnings are essentially used in machine learning algorithms, basically. So supervised learning is essentially used for classification and regression problems. Meanwhile, unsupervised learning methods are basically used to understand, because there is no output value data. You have to basically unsupervised learning takes a deeper look at the data, right? So it tries to understand the data more, let's say, in a more in its depth. Let's just say, right? And unsupervised learning is used in basically clustering. So for example, that's where unsupervised learning methods are used. So it basically uses to detect the patterns and similarities within just data. So going off of that, we started off with that, right, in the module, and we started off with decision trees, which was one of the first things that we learned in the course. So what are decision trees? Well, decision trees are basically flowchart-like structures that we use to essentially perform. It's like a tool that we use to basically figure out, basically for prediction. Yes, that's what I want to say. Basically, we use it for prediction. Now, decision trees have you have nodes, and then you have branches, and then you have leaf nodes, right? And so on and so forth. And each branch essentially represents an outcome of a test that you perform on that node. So, and each node essentially holds a class label inside it. So, and this is essentially an example of supervised learning. Now, decision trees are useful because one, they don't really require a lot of computational power, and number two, you're able to understand that what fields are the most important for classifying or predicting in this. But the biggest problem is, one, when you're growing a decision tree, it's extremely computationally expensive, and number two, it's that it's very prone to errors when it doesn't have a large data set to train itself on. So it makes a lot of errors then. So it really doesn't go to the depth of the data. Now before we started learning about classifiers, we learned about classifier evaluation techniques, right? So we learned about 4 attributes, which was precision, F measure, and sensitivity. My bad, that's 3. I think precision's second name is recall, and I think sensitivity the name for sensitivity as well was specificity. Yes, exactly. So we learned about how these 3 terms and these 3 tests basically allow us to understand how good a classifier is working or not. Basically be able to figure out how, give us a rating system, let's just say, for a classifier, right? And then we learned about our another classification technique, which was the naive Bayes classification technique. So the naive Bayes classifier helped us understand one, it's naive and it uses the Bayes theorem. That's why its name is like that. And naive Bayes, the reason that it's called naive is because it makes an assumption that the data is independent. So all the fields within the data are independent of each other. And Bayes, because it uses the Bayes theorem to essentially calculate some probabilities upon which it basically performs the predictions that it does. So basically meaning that every pair of data that's being classified is independent of each other. That's its naive assumption, basically. So it uses 2 things. It uses the data set is divided into 2 separate parts, which is a feature matrix and the response vector. The feature matrix is filled up with the vectors, right? But what are the vectors? They're the rows of data that you have, right? And the response vector contains the value of the class variables for each row of that feature matrix. So basically based upon the Bayes theorem, it performs a lot of calculations, which helps it basically classify efficiently. Now despite being extremely naive, it's still pretty good at classifying data. That's the interesting thing about Bayes' theorem. It's pretty accurate when it's classifying its data. Now, okay, so and this is like even though it's super simple, let's just say from to a fault, it's still really good in real world situations. We often use it for document classification and spam filtering and for emails. So that's one of the uses of that. Secondly, we learned about artificial neural networks. What are artificial neural networks? Well, maybe the second part of it rings a bell. Neural. So brain, right? So neural networks are artificial neural networks are based upon the neural, not based upon, but they mimic how neural networks within your brain often works. Now, the basic structure of the artificial neural network is that it has neurons, right? And it has let me think. It has so no sorry artificial neural networks are consist of nodes. Sorry, neurons are the ones that are the actual neural network. Artificial neural networks consist of nodes, and the nodes are basically, they take input data and they perform simple operations upon that data, and the result of those operations, whatever changes that it does to the data or whatever it gets from the data, is passed on to the next node, right, or the next neuron, let's say. And the output is called node value, and they're linked together, and their link has an associated weight with it. Now, so I think that's enough about artificial neural network, because if we start getting too much into it, it's gonna get extremely deep. But to maybe we should talk about what's next. We need to talk about gradient descent and backpropagation, and I think that's it, because we didn't do AI ethical concerns. So right, okay. So about neural networks, right? So coming back to them, they're also used, to classify and to classify and to predict. That's what they're used for, and so ANN uses basically gradient descent to learn. Right, that's one of the techniques it uses to learn, and learn and train itself on the data set. And I think that's pretty much enough for artificial neural networks. We're going over time. Okay, so thank you for listening to my summary. And yeah, thank you. Okay, bye bye.